From the vast emptiness of space, a solitary blue marble hangs in the dark. Our planet. Here, life isn't just a happy accident. It's the result of a long, complex, and sometimes violent natural epic. And what cradles all of this precious life? A thin, almost invisible blanket. The atmosphere. It's the Earth's enormous respiratory system, and its silent, ever-present shield. Let's rewind the clock about 4.6 billion years. To Earth's fiery birth. Volcanoes raged, spewing a thick, toxic atmosphere of carbon dioxide, methane, and ammonia. The sun's unfiltered ultraviolet rays scorched the surface. Nothing could survive there. But life, as they say, finds a way. Deep in the ancient oceans, billions of years later, tiny organisms like cyanobacteria were born. They began a process that would completely revolutionize our world. The Great Oxygenation Event. These little life forms started releasing oxygen. At first, this new gas simply reacted with other elements, but eventually, it flooded the atmosphere. When this free oxygen reached the stratosphere, something incredible happened. Bathed in the sun's intense UV rays, oxygen molecules, or O, were split apart. A lone oxygen atom would then join another O molecule, creating a new form, O, or ozone. This new ozone layer is deceptively thin. If you could bring it all down to sea level, it would be just 3 millimeters thick, about the thickness of 2 coins stacked together. But those 3 millimeters make all the difference. They are the barrier between us and deadly radiation from space, absorbing about 98% of the sun's most harmful ultraviolet rays, UVB and UVC. Without this shield, life as we know it simply couldn't exist on land. But the atmosphere does more than just shield us. It's also a massive temperature regulator. Gases like water vapor, carbon dioxide and methane act like a natural blanket, trapping heat reflected from the Earth's surface. We call this the greenhouse effect, and it keeps our planet at a comfortable average of 15 degrees Celsius. Without it, Earth would be a frozen wasteland at minus 18 degrees, with all water locked in ice. So, greenhouse gases are absolutely vital for life, as long as they remain in balance. Let's take a journey up through the layers of this amazing shield. The first layer, the troposphere, extends from the ground up to about 12 kilometers. This is where all our weather happens, the clouds, the rain, the storms we feel. High up in the troposphere are the jet streams, powerful rivers of air that steer weather systems across the globe, carrying storms and cold fronts from one continent to another. Above that is the stratosphere, home to our precious ozone layer. A strange thing happens here. The temperature actually increases with height. That's because the ozone is busy absorbing UV radiation, heating this layer up. Next up, from about 52.85 kilometers, is the This is the coldest part of our atmosphere, and it acts as a cosmic shooting gallery. Most meteors heading for Earth burn up here, creating shooting stars and protecting us from constant bombardment. Finally, we reach the thermosphere, which stretches out for about 600 kilometers. The air here is incredibly thin, but the temperatures can soar to hundreds of degrees Celsius. This is where the International Space Station and many of our satellites orbit. And it's here that nature puts on its most spectacular light show, the aurora. When charged particles from the sun collide with gases in our atmosphere, they create those shimmering, dancing curtains of light near the poles. For millennia, this atmospheric system worked in perfect harmony. But in the 20th century, our own industrial revolution dealt an unexpected blow to this delicate balance. In 1928, a new class of chemicals was invented, chlorofluorocarbons or CFCs. They seemed like a miracle. Non-toxic, non-flammable, and incredibly stable. They became essential in refrigerators, air conditioners, aerosol sprays, and foam manufacturing. No one could have imagined that these safe gases would become a terrifying threat to Earth's life support system. In the 1970s, two scientists, Mario Molina and Sherwood Rowland, made a shocking discovery. They theorized that when CFCs drifted up into the stratosphere, the sun's UV rays would break them apart, releasing a free chlorine atom. This single chlorine atom could then trigger a catastrophic chain reaction. It would tear apart an ozone molecule, then move on to the next, and the next. The most frightening part, a single chlorine atom could destroy up to 100,000 ozone molecules before it was finally neutralized. Their theory was tragically proven correct. In 1985, British researchers discovered a massive drop in ozone concentration over Antarctica. The media dubbed it the ozone hole. But why over the poles? The extreme cold of the polar winter creates unique clouds called polar stratospheric clouds. These clouds provide the perfect chemical surface for chlorine to unleash its destructive power on a massive scale. Every year, between September and November, this hole would grow, sometimes becoming larger than the entire continent of North America. The depletion of the ozone layer wasn't just an environmental problem. It was a global health crisis in the making. Direct effects on humans included skyrocketing rates of skin cancer, cataracts, and a weakened immune system. But the environmental damage was even more profound. Crop yields would plummet, and the very foundation of the marine food web, phytoplankton, which also produced a huge portion of our oxygen, was at risk from the intense UV radiation. But this isn't just a cautionary tale. The story of the ozone hole is one of humanity's greatest collective successes. Once the scientific evidence became undeniable, the world responded with unprecedented speed. On September 16, 1987, world leaders gathered in Montreal, Canada, and signed a historic treaty, the Montreal Protocol. It is, to this day, the world's most successful international environmental agreement. Nations agreed to phase out the production and use of nearly 100 ozone-depleting substances, including CFCs, and it worked. The concentration of these destructive gases in the atmosphere began to decline. It was a powerful demonstration that when science, industry, and diplomacy unite, we can avert global environmental catastrophe. However, the story has another twist. The chemicals developed to replace CFCs, called hydrofluorocarbons, or HFCs, were safe for the ozone layer. But they came with a new problem. They turned out to be incredibly potent greenhouse gases, some with thousands of times the heat-trapping power of carbon dioxide. In solving one crisis, we were inadvertently accelerating another. Global warming. So, in 2016, the world came together again to strengthen the Montreal Protocol with the Kigali Amendment. This new agreement aims to phase down the production and use of HFCs by more than 80%. Scientists estimate this single act could prevent up to half a degree Celsius of global warming by the end of the century. Critical step in our fight against climate change. Today, scientists are confident that the ozone layer is slowly but surely healing. If we continue to honor the Montreal Protocol, the ozone hole over Antarctica is expected to fully recover to its 1980 levels by around 2065. This is a monumental achievement. The atmosphere and the story of the ozone layer teach us a vital lesson. Our planet's environment is a complex, interconnected system. A small disruption in one part can trigger a disaster on a global scale. The ozone hole was a test from nature, and with the Montreal Protocol, humanity passed. We must now apply that same unity, determination, and respect for science to face the even greater challenge of climate change. This invisible blanket of air belongs to all of us, and protecting it is our shared responsibility. It is, after all, where life thrives. Thank you so much for watching. If you found this journey through our atmosphere fascinating, please give this video a like, and don't forget to subscribe for more stories about our incredible world. See you next time.